Welcome to Spring LIB.
In each part of this problem, we need to use concepts of electrolysis in order to calculate how long it will take to plate out, meaning to convert each one of these metals from their aqueous ion forms into their solid forms if we run a current of 100 amps through the solution. So starting in part A, we want to determine the time that it takes to plate out 1.0 kilograms of aluminum from aqueous Al3+. So that means that the reaction that is occurring is Al3+ being reduced by adding 3 electrons to plate out solid aluminum. Again, we want to know how long it takes to plate out 1.0 kilograms of aluminum. So that's our reference. We know that we need to first convert into moles of aluminum. So we know that 1 kilogram of aluminum is equal to 1,000 grams of aluminum. And then from the molar mass on the periodic table, we can say that there are 26.98 grams of aluminum for every mole of aluminum. And then we can see from this reduction that for every 1 mole of aluminum that we are plating out, that corresponds to 3 moles of electrons that were required to reduce Al3+ to Al. And now we multiply that by Faraday's constant, which is 96,485 coulombs per mole of electrons. And then we have a 100 amp current running through that Al3+ solution. So that's 100 coulombs per second. And we can convert the final answer from seconds into hours using the conversion of 1 hour is 3,600 seconds. Now, if we multiply all of those ratios together, we should get the final answer for how long it takes to plate out 1.0 kilograms of aluminum from aqueous Al3+. And that is about 30 hours. Now in part B, we want to know how long it takes to plate out 1.0 grams of nickel solid from aqueous Ni2+. So that must mean that we have Ni2+, we are adding 2 electrons to reduce it into Ni solid, which we can plate out. And we want to plate out 1.0 grams of nickel. And to convert this into moles, we use a molar mass from the periodic table again, which is 58.69 grams of nickel per mole of nickel. And from that reduction reaction, we see that for every 1 mole of solid nickel that we plate out, we required 2 moles of electrons to reduce Ni2+. And according to Faraday's constant, there are 96,485 coulombs for every mole of electrons, and we have a 100 amp current, so 100 coulombs per second. And when we multiply out those ratios, we get the total time that it takes to plate out 1.0 grams of solid nickel from Ni2+ to be about 33 seconds. And now finally for part C, we want to know how long it takes to plate out 5 moles of solid silver from aqueous Ag+. So we're starting with Ag+, an aqueous solution, and in order to convert to solid Ag, we need to add 1 electron to plate out that solid silver. We want to plate out 5.0 moles of solid Ag, and we know that based on that reduction reaction, every 1 mole of solid Ag was plated out by reducing Ag plus with 1 mole of electrons multiplied by Faraday's constant, 96,485 coulombs for every 1 mole of electrons. And then, again, a 100 amp current, so 100.0 coulombs per second. 1 amp is 1 coulomb per second. And we can convert to hours by saying 1 hour is equal to 3,600 seconds. When we multiply all those ratios together, we get a total time of about 1.3 hours.